Hello everyone. So today we are working with a pre-calculus algebra problem where we're asked to find a domain for which the function f of x equals x squared plus 3 is invertible. Then find the inverse of f of x. So in order to look at this problem, for me the easiest way to start off with is by looking at the graph of x squared plus 3 as shown in blue. And you can tell this function is not invertible because it doesn't pass the horizontal line test. And the horizontal line test said something along these lines. Draw a horizontal line through your function. And if it hits, and this can be anywhere along the function, and if it hits two values, then it is not invertible. And that's what happens here, okay? So right now, there's no way of actually finding an inverse. However, what we can do is this. We can restrict the domain of your function so that it is invertible. And what do I mean by that? Well, let's take a look at the graph and let's concentrate on the vertex here, which is in red. And if you looked at the graph to the left of the vertex or to the right, in this case I'm with the red to the right, and this would be all values of x greater than or equal to 0, this would make f of x invertible, because if you restrict your domain to x greater than or equal to 0, when you draw a horizontal line through any part of that graph, that'll just hit the graph one time, so it'll pass the horizontal line test. So the function is invertible. So that's the thing, is that you want to restrict the domain here, and basically that you take out a part of the graph for which when you draw a horizontal line through part, it will now pass. So that's what we did. Now you could have also picked x to be less than or equal to 0 here. That would have worked out as well. There's actually many ways of answering this question. And again, I would go ahead and, just to show this, I would draw a horizontal line and it would pass the horizontal line test here again. So that works as well. So you have more than one choice. So f of x equals x squared plus 3 when x is greater than or equal to 0 would be a invertible function now. Okay, so again, if you can graph and restrict the domain for which the graph would now pass the horizontal line test. That's what we're saying. So to actually find the inverse part, here's what I'm going to do. I'm going to take my function, and I'm going to first of all start by rewriting f of x as y. Really not necessary step at all, but traditionally it's written out this way, and I'm not going against tradition right now here. So then the next step is this. You're going to switch the x into y. And you're going to, in your third step, to find the inverse to solve for y. So I'm going to subtract 3 from both sides and equal it to y squared. And I'm going to take a square root of both sides. So y is plus or minus root x minus 3. Now, only one of these will work, though, for my inverse function. It's not either or. It's actually just the square root of x minus 3. And why is that? Because when you restricted the domain, you said x was greater than or equal to 0. Or in other words, the x's were positive. When you look at a domain of a function, gives you x's, and your inputs are x's, your outputs are y's. An inverse function, the inputs are y's and the outputs are x's. So I want my x's are positive, so what I want is, this right here should just give me positives, and that's why you choose the positive, and there you go. Okay, so again, restrict the domain of your function according to the graph. Now, some people ask me, well, is there a way for me to see this without graphing it? And there is, doing this process without graphing, and there is, but it's a little more complicated here, so I'm kind of restricting these problems to the cases where you can graph this. And this often happens with quadratics or things of an even power. And when it's just like an even power x to the x squared plus 3, or like x4 minus 1, whatever, just like two terms, best thing you can do is to look at where the vertex would occur, if possible. That's usually going to help you out with these. All right, well, I hope this helps. Thank you for your time.